maps of urban islands using only crowdsourcing data. So data either from net stations, like visual, but also from cars and citizen cars. So that's a very novel things in the community. So I will first talk about the data, and especially on the cars. So it's not instrumented cars by scientists, it's the citizen cars. You can have on your car dashboard the air temperature that is printed, and in most modern cars, some of them are connected, and the data is sent back to the manufacturer with air temperature, but also vehicle speed and motor information and so on. And so we had access to 2.5 years of this type of data for the PSA company. And this data is pretty interesting to use to map the air temperature because first it's measure the air temperature and the data is in the middle of the street. But an issue is that you can see in the middle of the white circle, this is the sensor. So it's black, it's very small. So we can expect a lot of error on the sensor, and also there are some variability in the amount of vehicles that are available. At night, very few vehicles, but during the day, we have a lot of cars. So first, she made a small experiment with one meteorological station in red, and she studied the air temperature when the car is stopped in the white bonds, and when the car is moving. You see that there is a strong bias when the car is stopped because there is an overheating of the sensor. So in all the data and afterwards, we remove all the vehicle speed smaller than 10 kilometers. But we see that there still is a bias between the air temperature from the base station and the car, and there is an effect of solar radiation. But surprisingly, it was very simple to correct this bias. It was just a linear bias between the air temperature error and the solar radiation. So, we like error. And so when we do the corrections, you can see that there is a very small error between the car temperature and the air temperature measured by meteorological stations. So this was done in 2 cities where there was a network of urban stations. So we are pretty happy with this type of data and really use it. So this is an example of application for the city of Dijon. So this is a medium-sized city. I will talk more about it later on. But during the day, we see that there is not much urban environment, so it's pretty homogeneous temperature, while during the night you have 2 degrees urban environment. And also in the west there is a valley with catalytic flows and thermal inversion, and so cold temperatures that are retrieved by the cars along the road there. And it fits pretty well with the meteorological station, the small circles. So this was done on the whole summer 2018, so 5 years ago, and there is a good accuracy of the measurements by the car. So that's nice there. But the advantage is that we can also map now the urban environment for any cities where you have enough cars. So this is an example from Barcelona, Spain. And on the left, during the day, you can see the effect of the sea breeze, where air temperature is cooler on the city because it's near the coast, and then the air temperature increases inland. And then on the right, it's during the nighttime, and you have a strong urban environment on average during summer, so 6-7 degrees in Barcelona. It's pretty high, but it is a large city. And this was done for on average on the summer. So that's so there is now a new challenge because these maps are for hourly data where we have a lot of cars, but now we would like to have to specialize this data, but at hourly time scale where you have, of course, much less data. And that's what I will now explain in the following of the talk. So the other data we used, we have well-known net stations. So there are citizen stations, there are pretty good spatial coverage, especially in Europe. And there is also a 10-year literature on this type of data with control quality libraries that were used in this study too. Then there are some issues that a lot of error linked to the location where the station is located, for example, just on the balcony or against the walls, and more. Unfortunately, not in general in sheets in cars. So we have these two types of data, and now the objective is to you merge these two types of data into a city. So this is the shape of the city, and what is the air temperature inside the city? That's the question. And also we want to take the car data, the Netatmo data. So for the Netatmo data, there was prepared by the Code Plus Quality Control of CNRS et al. And for the car, there is a correction I explained below, so removing the low speed cars and correction of solar radiation. This is also explained in the paper by Marcus et al. 2020. Then we want to specialize this data. So we need to merge two types of data, and they are different. And then include also covariates and special autocorrelation. So that's to do this, it was pretty complicated, especially for a city where the geography you have hills on the west, plains on the east. The city is concentric, pretty classical. And we use the city because there is, as I said, the measurements network. So if I use a Bayesian hierarchical model, so the philosophy behind this model is you have a prior, so that's a priori knowledge. So the knowledge you have is there are some urban feature or attitudes that is interesting, and we have knowledge about the error of the data. Then we have the observations, and we cross the two information to produce a posterior, which is information with updated by the observations. So typically maps of urban environment, but not only, because for each point we produce not only the value of the median value, but also a PDF of the air temperature. So that's statistical information for each point. And then you can extract the most probability node. So for the now we see what happens during the night when you have few cars, and during the day when you have a lot of cars. So on the night, you have all the Netatmo stations in the city center, and only a few cars typically on the highway on the east. While during the daytime, so rush hour in the morning, you have a lot of cars that so there are some different amount of data. And then we can use the Bayesian model to produce maps now on the whole territory, not only along the road, for the nighttime or for the daytime. And we can see that in the nighttime, most of the information comes from the Netatmo data and the urban information, so building 8, building of city. While during the rush hour, most of the information comes from the car. And we see also the remaining katabatic inversion in the early morning. And also on the southwest, you have hot temperature because this is hills facing east. So in addition to the air temperature and function, you have information also on the accuracy of it, expected accuracy, uncertainty of the model. And where you have less information, you have more uncertainty. And in addition to that, the Bayesian model will also give information on the influence of the covariance you have implemented to altitude, building height, and building density. And we see that there is a lot of impact of altitude during the night because of the effect of orography, that is pretty, you have 400 meters of difference between the city and the top of the hills. There is also a large influence of building density, but not much of building height. And that's because there are not large variation in building height in Dijon. But we can see that when which parameters is the most important. And finally, so if I wanted to see what was interest to use to have access to two sources of data instead of one. So there is so she compared the model with only the Météo section, only the car, or only or both, and we see that Météo section is pretty uncertain, cars are pretty good, and when you use both, it's better. And also comparing about local climate zones, you can see that during the day, the estimation of the air temperature by this statistical model is pretty good everywhere. During the night, it's more difficult because outside the city, you have no data because you have much less cars, and so you have uncertainty in the green areas outside. But in all the urban locations, even season 9, it's pretty okay. So this is to conclude. So Eva performed a bit Bayesian model, so that allows to add some type of other type of data, maybe for example isoscale model data that could be available. And there is also a very high performance of the data from citizens car. That's most pretty surprise for us. That was the data was so good. And there is a better specialization when we use also the Météo station. So what can we do with this? We can validate numerical model. So this is a simulation of a interface over Paris. And we see on the right an urban plume in air temperature estimated from the Météo station and cars, and the simulation by the model on the left. So, thank you very much.
Questions for Valéry? Questions for Olivier? Okay, right in the back. Please. Get my steps in today.
Thanks for the very interesting presentation, and impressive to see how good the quality is of activity by cars. My name is Pierre-Simon. I was wondering, cars travel on asphalt.
Yes.
So how could we estimate would be the accuracy of urban park, for example? Because you have to extrapolate it beyond the range of the asphalt.
Yes. So the issue is that you will need to have a road inside the park. So for example, for Paris, here you can see there are some the two big parks east and west of Paris, and they are cooler. You have this function because there are some roads crossing this park. So you can, if you have a small park without a road inside, you cannot capture this information. And in that case, for the specialization model, you would have to include this information in the morphological data on the land cover, but you do not have, of course, this data from the past. And you can see also in the northwest, a very cool area, it's a forest with a road inside the forest.
So you actually see it through the affection from poor air from parks entering the asphalt road area. And if it's small, the park is very large.
Yeah, we suppose that the air temperature of a moving car, measured by a moving car above the road, is the same as the park. Especially in nighttime, it's not an issue. the daytime you have some correction due to the solar radiation that can also take into account this effect of heating by the work.
Thank you.
Thank you so much. Let's keep that up front. And we have